Our objective in this lesson is to solve real-life problems involving logarithmic expressions. Prerequisite knowledge needed are properties of logarithms and laws on logarithms. So why use logarithms? One reason is to express huge numbers. Richter scale that measures energy waves emitted by earthquakes uses a logarithmic scale. To further illustrate, let me use this line that represents the magnitudes of earthquakes. Let us recall 3 earthquakes that struck our country for comparison. An earthquake with a magnitude of 5 hit Batangas last October 2020. A magnitude of 6 earthquake struck Central Luzon last April 2019. The Morro Gulf earthquake in 1976 that claimed 8,000 lives has a magnitude of 8. So what these magnitudes mean? Since Richter scale uses a base 10 logarithm, 5 here means that this is equal to the logarithm of x to the base 10. To solve for x, let us convert this into exponential form. So we have 10 raised to 5 is equal to x. This means that 5 here is actually equal to 10 raised to 5. It follows that this is 10 raised to 6 and this one is 10 raised to 8. 10 raised to 5 is 100,000. 10 raised to 6 is 1 million. 100,000 times 10 is 1 million. So a magnitude of 6 means 10 times is stronger than a magnitude of 5. This is another 10 times and another 10 times. So 10 times 10 is 100 times 10 is 1,000. So an earthquake with a magnitude of 8 means 1,000 times is stronger than an earthquake with a magnitude of 5. But wait, stronger in what? An increase of 1 in Richter scale means a tenfold increase in the amplitude of the wave, but not a tenfold increase in the size or energy released by the earthquake. A better measure of the size of an earthquake is by the amount of energy released by it. And it is given by the formula, the logarithm of E is equal to 4.4 plus 1.5 m. E here is the energy in joules and m is the magnitude in Richter scale. Now let us convert this into exponential form. This is a common logarithm, so the base here is 10. So 10 raised to 4.4 plus 1.5 m is equal to E. Let us compare the energy released by an earthquake of magnitude 6 and magnitude 5. So let us replace this with 6 and let us also replace this with 5. To compare, let us get the ratio of these earthquakes. So we have 10 raised to 4.4 plus 1.5 times 6 divided by 10 raised to 4.4 plus 1.5 times 5. And this is equal to 31.62. This means that an earthquake with a magnitude of 6 has 30 times more energy than an earthquake with a magnitude of 5. On a Richter scale, the magnitude denoted by R of an earthquake is given by the formula R is equal to the logarithm of quantity I over I sub O, where I is the intensity of the earthquake being measured and I sub O is the reference intensity. The 1976 earthquake in Mindanao is the deadliest earthquake recorded in the Philippines, with a magnitude of 8.1. How many times does this earthquake more intense than the 5.6 magnitude earthquake that happened in Batangas last October 4, 2020? Let us recall our formula. R here is the magnitude. Let us start with the earthquake that happened in Mindanao. It has a magnitude of 8.1. So this will be 8.1. I sub m stands for the intensity of the earthquake that happened in Mindanao. Let us switch places. Let us convert this into exponential form. So my base here is 10. So 10 raised to 8.1 is equal to I sub m over I sub O. Cross multiplication, I sub m is equal to 10 raised to 8.1 of I sub O. Now, let us have the earthquake that happened in Batangas. It has a magnitude of 5.6. I sub B stands for the intensity of the earthquake that happened in Batangas. Again, let us switch places. Let us convert this into exponential form. So 10 raised to 5.6 is equal to I sub B over I sub O. Cross multiplication, I sub b is equal to 10 raised to 5.6 of I sub o. To compare, let us get the ratio of these two. So we have I sub m over I sub b is equal to 10 raised to 8.1 of I sub o divided by 10 raised to 5.6 of I sub o. So I sub o will be cancelled out. Loss of exponent, we have the same base. We copy the base. We subtract the exponents. 8.1 minus 5.6 is 2.5. And 10 raised to 2.5 is 316.23. This means the Mindanao earthquake is approximately 300 times more intense than the Batangas earthquake. Let us have the same problem, but I'm going to introduce a new formula. R sub m stands for the magnitude of earthquake that happened in Mindanao, and R sub b is the magnitude of earthquake that happened in Batangas. I sub m is the intensity of the earthquake in Mindanao, and I sub b is the intensity of the earthquake that happened in Batangas. Just remember that these two and these two go together. So let us substitute. The magnitude of earthquake in Mindanao is 8.1, and the magnitude of earthquake in Batangas is 5.6. 8.1 minus 5.6 is 2.5. Let us convert this into exponential form. So the base here is 10. So 10 raised to 2.5 is equal to I sub m over I sub b. And 10 raised to 2.5 is equal to 316.23. Round off to the nearest hundreds. This is 300. Cross multiplication, I sub m is equal to 300 of I sub b. This means that the intensity of earthquake in Mindanao is equal to 300 times the intensity of earthquake in Batangas. So we have the same answer. Let us have another problem. Earthquake A is 20 times stronger than earthquake B. Earthquake B registered a 3.1 magnitude on the Richter scale. What did earthquake A register on the Richter scale? Since we are comparing two earthquakes, let us recall our formula. So the magnitude of earthquake A is not given. The magnitude of earthquake B is given, and that is 3.1. The ratio of their intensity is also given, and that is 20 times. Earthquake A is 20 times stronger than earthquake B. Let us substitute those. So we have R sub A minus 3.1 is equal to the logarithm of 20. Since we are asked to determine the magnitude of earthquake A, let us move negative 3.1 on the other side. Logarithm of 20 plus 3.1 is equal to 4.4. So, earthquake A registered approximately 4.4 on the Richter scale. There is another formula in measuring the magnitude when energy in joules released by the earthquake is given, and that is R is equal to 2 over 3 times the logarithm of E divided by 10 raised to 4.4, where 10 raised to 4.4 is the energy released by a very small reference earthquake. Let's have an example. Suppose an earthquake released approximately 10 raised to 10 joules of energy. Letter A, what is the magnitude of this earthquake on the Richter scale? And letter B, how much more energy does this earthquake release than the reference earthquake? So let us start with letter A. Let us copy our formula. Let us substitute 10 raised to 10 for our E here. Loss of exponents, when you have the same base, you copy the base and you subtract the exponents. Then, property of logarithm, since this is a common logarithm, the base here is 10. When your x and b are the same, the answer to this expression is the exponent of your x. So this is 2/3 times 5.6, and this is equal to 3.73. This means that 10 raised to 10 joules of energy is equivalent to 3.73 on the Richter scale. Letter B, to determine how much more energy does this earthquake release than the reference earthquake, let us get the ratio. So once again, law of exponents, copy the base and subtract the exponents. 10 raised to 5.6, and this is approximately equal to 398,107. This means that the earthquake released approximately 398,107 times more energy than the reference earthquake. Another application of logarithm is in sound intensity. Decibel, denoted by dB, is a common measure of sound intensity given by the formula dB is equal to 10 times the logarithm of I divided by 10 raised to negative 12. dB or decibel is the level of sound, I is the sound intensity measured in watts per meter squared, and 10 raised to negative 12 is the reference intensity. The human threshold for pain begins at 120 decibels. Eardrums will start to burst at 160 decibels. Letter A. What is the corresponding sound intensity of 120 decibels? And letter B. How much more intense is 160 decibels than 120 decibels? So let us recall our formula. We are asked to determine the corresponding sound intensity of 120 decibels, so dB here will be equal to 120. I sub 120 stands for the intensity of 120 decibels. Let us simplify this. Let us divide both sides by 10. So 10 and 10 will be cancelled out. 120 divided by 10 is 12. Let us convert this into exponential form. My base here is 10. So I have 10 raised to 12 is equal to I sub 120 divided by 10 raised to negative 12. By cross multiplication, I sub 120 is equal to 10 raised to 12 times 10 raised to negative 12. Laws of exponents, let us copy the base and then let us add the exponent. So we have 10 raised to 12 minus 12. 12 minus 12 is 0. 10 raised to 0 is 1. This means that the intensity of 120 decibels is 1 watt per meter squared. Next, to answer letter B, let us first determine the corresponding intensity of 160 decibels. So let me take a little shortcut here. Imagine that this is 160. So 160 divided by 10 is 16. So this will be 10 raised to 16. This will also be 16. And this one will also be 16. So I have I sub 160 is equal to 10 raised to 16 minus 12. And 16 minus 12 is 4. So the intensity of 160 decibels is 10 raised to 4 watts per meter squared. Now to answer letter B, let us compare the ratio. So 10 raised to 4 over 1 is still 10 raised to 4, and that is equal to 10,000. So this means 160 decibels is 10,000 times more intense than 120 decibels. Let us have another example. A vacuum cleaner has a noise rating of 70 decibels, while a jackhammer has a noise rating of 100 decibels. How much more intense is the jackhammer noise than the vacuum cleaner noise? Remember the formula that we use when we compare two earthquakes? We're going to use the same concept when comparing the sound intensity. So this one is the decibel of the jackhammer, and this one is the decibel of the vacuum cleaner. This one is the intensity of the jackhammer, and this one is the intensity of the vacuum cleaner. The decibel of jackhammer is 100. The decibel of the vacuum cleaner is 70. So let us substitute those values. 100 minus 70 is 30. Let us simplify this. Let us divide both sides by 10. So 10 and 10 will be cancelled out. 30 divided by 10 is 3. So we have 3 is equal to the logarithm of I sub j over I sub b. Let us convert this into exponential form. The base here is 10. So I have 10 raised to 3 is equal to I sub j over I sub b. Cross multiplication, I sub j is equal to 10 cubed times I sub b. 10 cubed is equal to 1,000. So I have I sub j is equal to 1,000 times I sub b. This means that the intensity of the jackhammer is equal to 1,000 times more than the intensity of the vacuum cleaner. Another application of logarithm is computing the pH level. In chemistry, the acidity and alkalinity of a substance is determined using this formula. This one is called the hydrogen concentration, measured in moles per liter. If pH level is less than 7, it is acidic. If pH level is greater than 7, it is basic. And if pH level is equal to 7, it is neutral. Let's have an example. You test the hydrogen ion concentration of your pineapple juice and it is 0.0006. Determine the pH level of it and tell if it is basic or acidic. So let us recall the formula. Let us substitute 0.0006 to our formula here, and negative log of 0.0006 is equal to 3.22. Since 3.22 is less than 7, then this is acidic. Another example, if a vinegar has a pH level of 2.1, what is its hydrogen concentration to the nearest thousands? So the pH level is given. Let us substitute it here. So 2.1 is equal to the negative logarithm of the hydrogen concentration. Let us divide both sides by -1. So this will be negative 2.1. And then let us convert this into exponential form. So the base here is 10. So I have 10 raised to negative 2.1 is equal to the hydrogen concentration. And 10 raised to negative 2.1 is 0.007. Another application of logarithm is in compound interest. I hope you still remember these formulas from our lesson solving real-life problems involving exponential expressions. So A here is the future or the ending amount. P is the principal or beginning amount. R is the interest rate, should be given in decimal. N is the number of compoundings a year. We have several compoundings a year. If it is annually, N is equal to 1. Semi-annually, N is equal to 2. Quarterly, N is equal to 4. And monthly, N is equal to 12. Sometimes there is daily or weekly. And T here is the number of years. Let's have an example. Will wanted his investment to double. How long will it take if he invests his money in a bank that offers 4% compounded monthly? Let us identify the given here. A is the future value. It says here, Will wanted his investment to double. So A will be twice of the investment. Since the investment is not given, we're still going to make use of letter P. And then how long? So we are asked to solve for the T. And then 4%, that is 12.04 in decimal, that is the interest rate. Compounded monthly, so it means our N is equal to 12. So let us substitute those. So 2P stands for twice of the principal amount, and P is the principal amount. 0.04 is the interest rate. This is 12 because compounded monthly. And we are asked to solve for the value of T. So first, let us divide both sides by P. So P and P here will be cancelled out. Then let us simplify this, and it is equivalent to 1.0033. And then let us take the log of both sides. I can apply now the power rule. I can bring down 12T here in front. Since I only want the value of T, I'm going to divide both sides by 12 and log of 1.0033. So 12 and 12 will be cancelled out, as well as log of 1.0033. So T is equal to the logarithm of 2 divided by 12 times the logarithm of 1.0033. And this is 17.53. So it means it will take 17.53 years before the money of Will gets doubled. Another application is in continuous growth. So this formula is used whenever you do not have N. So there is no number of compoundings. So P is the final population. P sub O is the initial population. E is an irrational number approximately equal to 2.71828. R is the growth rate, and T is the number of years. So let's have an example. The population of the Earth is growing at approximately 1.3% per year. At the beginning of the year 2000, the Earth's population was just over 6 billion. After how many years before the population tripled to 18 billion? So let us identify our variables here. The final population, we are looking at 18 billion. The initial population is 6 billion. E is already given. R is 1.3%, that is 1, 2, so 0.013 in decimal. And the number of years is what we are asked to solve. Let us recall the formula. Let us substitute the values that we have identified earlier. Let us divide both sides by 6 billion. So 6 billion will be cancelled out. 18 billion divided by 6 billion is equal to 3. Since we have E here, I'm going to take the ln of both sides. I can now apply power law, so I'll bring down 0.013t here in front. Property of logarithm, ln E is a logarithm whose base is E. Therefore, ln E is equal to 1. So this is just ln 3 equals 0.013t. Then I'll divide both sides by 0.013, so 0.013 will be cancelled out. So t is equal to ln 3 divided by 0.013, and that is approximately equal to 85 years. So this means count 85 years from 2000 and the Earth's population will be tripled. Another application of logarithm is in bacteria culture. Let's have an example. Suppose that a colony of bacteria doubles its population every 10 hours. The growth of bacteria is given by C is equal to 100 times 2 raised to t over 10. If the initial population of the bacteria is 100, after how many hours will it be at least 500? So we want a bacteria that is at least 500. So C should be greater than or equal to 500. Now C is equal to 100 times 2 raised to t over 10. Let us simplify this. Let us divide both sides by 100. So 100 here will be cancelled out. 500 over 100 is 5. Now, let us take the logarithms of both sides. Applying power law, I can bring down t over 10 here in front. And then to eliminate 10 here, I'm going to multiply both sides by 10. So 10 here will be cancelled out. So I have t log of 2 is greater than or equal to 10 times the log of 5. Since I only want the value of t, I'm going to divide both sides by log of 2. So log of 2 will be cancelled out. So I have t is greater than or equal to 10 times the logarithm of 5 over the logarithm of 2. And that is 23.22. So it means I need at least 23.22 hours before the bacteria reach 500. Now it is time to check your understanding. Pause this video for more time. Let us answer. Since we are looking for energy, we're going to make use of this formula. R here is the magnitude and it is given, so that is 6.6. Let us simplify this. Let us eliminate 2 over 3 here, and we can do that by multiplying both sides by the reciprocal of 2 over 3, and that is 3 over 2. So 2 and 2 will be cancelled out, as well as 3 and 3. 3 over 2 times 6.6 is 9.9. Let us convert this into exponential form. Our base here is 10, so 10 raised to 9.9 is equal to e over 10 raised to 4.4. Cross multiplication, e is equal to 10 raised to 9.9 times 10 raised to 4.4. Loss of exponents, let us copy the base and then add the exponents. 9.9 plus 4.4 is 14.3. So the earthquake that has a magnitude of 6.6 released an energy equal to 10 raised to 14.3 joules. Gets?